Section 3, Making Maps with ArcGIS. In this section, we'll learn about core cartographic principles. You'll then learn different methods for data classification and cartography. You'll use different cartographic methods such as choropleth mapping, graduated symbols, and dot density maps to visualize your data. And then you'll learn how to create a map layout in ArcGIS and export your map to an image file. Employing cartographic principles. In this video, we'll learn about visual variables in cartography. We'll also learn about proper color selection and schemes, and how to use them in a cartographic process. Finally, you'll learn about ColorBrewer and how to choose appropriate colors for your map. You'll sometimes hear the terms cartography and GIS used interchangeably, but they are not the same thing. Cartography and the science of mapmaking has been around for a very long time. GIS, as we've learned, refers to the entire process of working with spatial data, from data management to data analysis to also visualization. Cartography can be interpreted as both an art and a science. When designing a map, you want to think about how do you create a visually attractive and also visually convincing product, but also a product that maintains fidelity to the underlying scientific principles that you're trying to communicate. When you're designing a map, you should take into account these key considerations. First, think about what are you mapping? What is the topic you're trying to communicate? And how do you choose visualization strategies to best align with how people understand and will best interpret your topic? Second, think about who is your audience. If your audience is a group of scientific professionals, they might interpret a map one way, but if your audience is the general public, they might interpret a map a very different way. And also, in what format will you be presenting the map? Are you creating a map for display on the web, an interactive map, or a static PDF map to be viewed in someone's web browser? Or is it going to be printed off in black and white in a report for distribution on paper? All of these different factors are important to take into account when thinking about your visualization decisions. When creating maps, you want to be able to show how things are similar and also how things are different across space. And to do that, we use visual variables. A key visual variable in cartography is location, where an object is on a map. Again, if you're trying to show cities in the United States, New York City is in a different location from Los Angeles. As such, their positions, their locations on the map should be different. You can also use shape to show variation. You think about a reference map, for example, or a road map in which a playground or a campground or a restroom might be represented with different symbols that align with map readers' understanding of the topic. Size can also be used as a visual variable. You might use a smaller shape or a smaller size object to represent a smaller quantity, and then a larger object to represent a larger quantity. Orientation is also important. You might think about the direction of arrows to show the flow of traffic or the flow of migration between countries or shipping routes. We can also use texture, a filled shape, or a dotted shape, perhaps to show different land uses on a map. Also, color is very important for showing variation on a map. And when thinking about color, we can characterize it in relationship to its hue, lightness or value, and saturation. Hue is color is commonly understood, so thinking reds, blues, greens, etc. We can then also modify the lightness or value of the color, the extent to which it is light or dark, and its saturation, so the vividness of the color. When choosing colors, we arrange then those colors into different schemes. The first example is a sequential scheme, which might vary between light and dark, using a couple different hues or maybe just a single hue. The example shown is a variation in light blue to dark blue, which is best used for showing variation in an attribute from low to high or high to low. For example, the light blues might be used to represent low poverty areas, and the dark blues representing high poverty areas. A diverging scheme has more intense colors on either end of the color ramp, and neutral color in the middle. This is best used when there are extreme values in your data that you want to highlight. For example, you might think about population change, in which significant population loss on the one hand is significant, and also significant population growth on the other hand is significant. No population change might then be represented by a more neutral color in the middle. Qualitative scheme, the third example on the screen, is best appropriate for nominal or categorical data. If there are different categories that you want to represent, you might choose different hues for each of those categories. In my opinion, the best place to go on the web for advice about color and cartography is ColorBrewer. And you can visit ColorBrewer at colorbrewer2.org. ColorBrewer allows you to view scientifically tested color palettes in this interactive interface. We can choose a number of data classes. We can specify the nature of our data, sequential, diverging, or qualitative, and then pick a color scheme that's appropriate for our data. Here we see multi-hue sequential palettes, also single-hue palettes. We can click on a palette, and we get a preview in this map view to the right. We can change between diverging palettes or qualitative palettes. One great feature of ColorBrewer is that you can check these boxes to only show colorblind safe, print friendly, and photocopy safe palettes. We've discussed in an earlier video thinking about individuals who might be viewing your maps who have red-green color blindness. As such, certain color palettes would be less interpretable to those individuals. By checking the box for colorblind safe, you can eliminate color palettes that would be difficult for colorblind map viewers to understand. For example, here we have some color palettes in the diverging category that vary between reds and greens. We check colorblind safe, those are removed from our options. Additionally, we can choose this photocopy safe box to show color palettes that are going to show up when printed in black and white. We can see here there's only one qualitative palette with 3 data classes that would show up well in black and white. And indeed, if we increase the categories, even sequential palettes are difficult to represent well in black and white or grayscale.